Mr. Healy.
Chairman Carter, Ranking Member Wasserman Schultz, and distinguished members of the subcommittee, thank you for having me here today. I'd like to start off with a question. What if our military could produce electricity through a mobile generator that provided better electricity than even the US grid? Well, I'm here today to introduce a new superior power generation technology, one that's reliable, efficient, fuel flexible, and mobile. I founded Hyliion out of my dorm room at Carnegie Mellon, and it's been an American startup story. We took the company public on the New York Stock Exchange in 2020. We've raised over $700 million of capital, and we've begun delivering our Carno modular power plant, which we believe will fundamentally change how electricity is produced. If there are three key things to remember about what we're doing, it's first, that it's one solution that can be used across all applications. Second is it offers fuel flexibility, reliability, and the performance the military needs. And the third is it's manufactured through 3D printing, which enables us to make it here in the US. So let's go back to that first point about one solution across all applications. What if military vessels, autonomous vessels, what if bases, what if vehicles could all use the same power generation solution, leveraging the same parts and the same service across all applications? The Carno generator is designed to be scalable as well, starting with a 200 kilowatt base unit that then can be stacked together to deliver multi-megawatts for military bases. That base unit, just for reference, is about the size of a bed of a pickup truck, so it's extremely compact. This vision is already becoming a reality. We actually just delivered our first unit to the Navy, and they're going to not only be testing it for autonomous vessels, but they're also going to be testing it for stationary applications. The second point I made was why Carno? So this is a fuel agnostic solution. It can operate on over 20 different fuels, including diesel, natural gas, propane, JP8. So imagine if our troops are deployed somewhere in the world where it's kind of unsure of what fuel they're going to have available to them, and it's unsure if that fuel is even contaminated. Our technology eliminates those concerns because now the system, you start feeding it fuel and it will sense what fuel it's receiving, adjust accordingly, and deliver electricity. Now, reliability is also key. So the system's designed with only one moving part, and even that part glides on gas bearings. It's similar to like an air hockey table. So that eliminates the need for oils, eliminates maintenance or substantial maintenance, and eliminates lubricants. So as you think about like autonomous vessels where there isn't anyone on board to actually maintain the engines, reliability is critical. Additionally, we want to look at efficiency. So the Carno generator, when you compare it to the grid is about 36% efficient. So, your standard wall outlet. The Carno generator will be able to deliver efficiencies up to 50%. That means that we're going to use less fuel to make the same amount of power. Now, it does all these things while also having a very low noise profile. It's similar noise level to like an air conditioning unit. And it also has a low heat profile, meaning the system is less detectable. Any one of these advantages alone could convince you to move away from diesel generators, but we've been able to package all of this into one solution, our Carno generator. So the question comes up of like, well, why hasn't this been done before? And that brings me to my third key point, which is 3D printing. So if you go back 200 years ago, there were steam engines, there were diesel engines, there was this thing called a Stirling. Engineers always knew that Stirlings could be or would be the most efficient way of making power, but you could never manufacture a Stirling. Fast forward to today, thanks to advancements in 3D printing, we're able to make parts like this one here that are extremely complex, allow us to unlock efficiencies that now make Stirlings a reality, or as we like to call it, the Carno generator. So I think this is going to be passed around. So I want to be transparent with where we are in this process. As I shared, we just delivered our first unit to the Navy, and we have other early adopter customer units planned through the middle of this year. We believe the system will deliver everything I've shared today, but we are still in the final stages of development. We're testing the system and continuing to refine it. So as we go forward, we'd like to expand our relationship with the military, especially as we start scaling. We've already set up manufacturing both near Austin, Texas, as well as in Cincinnati, Ohio. Yeah, Austin. And so that is going to ensure that this is domestically produced. Chairman Carter, Ranking Member Wasserman Schultz, and distinguished members of the committee, our military has been known for having the best technology, and we need to make sure that remains true for power generation as well. With Hyliion's Carno power plant, we're delivering the three key things that are important. It's one solution that can be used across all applications. It offers fuel flexibility and reliability, as well as it's made here in the US, thanks to 3D printing. Thank you.
These new technologies, like 3D printing and additive manufacturing, hold a promise. Where's the core stand on the actual use of these? And what research do you have on their reliability and strength in both cold and hot weather? Anyone else want to comment on, I know we're all talking about seismic, and that's important, but what about the various heat levels we would, now, would it be what you're making be viable in Alaska or in the Arctic, as well as where I live in Texas, where it's hot? That's a good question. I like, as you've talked about what you're doing, are you looking into those things? Because I think that's very important.
I can maybe share a little bit about that. So just going back to your last question of the reliability of 3D printing. So that part I shared was made through 3D metal additive. Chances are if you flew to DC, greater than 50% chance the plane you were flying on was powered off of additive parts. So this has already been approved by the FAA. It's being used regularly. So additive is real. It's happening. It's being leveraged today. In terms of the ability to operate in different environments, that part that got passed around is made out of cobalt chromium, one of the most resistant metals to heat and cold as well. And so our system is designed to be able to operate in the extreme cold, like negative 40°C, as well as north of 40°C. Right, so that means it can go to Alaska, it can go to Texas, and actually one of the unique things is it actually likes the cold. It actually performs better in the cold. So we're actually looking forward to a Navy deployment that is going to be going to Alaska.
Mr. Healy, I am really, thank you, Mr. Healy. I am really intrigued by your development. One of the things that I'm really concerned about for America's defense is, these electromagnetic pulses. And is your generator protected from those EMPs? Or can it be?
Yeah, thank you, Congressman. Today, it is not protected from EMP attacks, but what I will share is through our journey, we've been working with the Navy, and the Navy has continued to give us military specs that we need to be able to meet, and then our engineering team goes and achieves those. A perfect example is Navy's going to run on diesel fuel. They wanted to be able to run on up to 20% contaminated with salt water diesel fuel. So then we go and we engineer the system to be able to do that. So that's something if the military is interested in, we'd be happy to explore.
That is pretty amazing, actually.
Mr. Healy, thank you for your presentation. I was not familiar with what you're doing, and I'd love to learn more. I'd love to get a deeper dive on it. Sounds like you've figured out the better and the faster at scale. Will this be cheaper? It seems like it would be, just with all the problems it solves.
So we expect that upfront cost will be more than a conventional diesel generator, but then it really comes down to what's your ROI, what's your payback, and there's two key advantages that we're offering. So one is that improved efficiency, which means you're just going to use less fuel, which is the majority of cost of operating a generator is the fuel that goes into it. And then the second is the lower maintenance. So we're finding that depends on the industry. Actually, in military applications where fuel is very expensive, in some instances, it's going to mean you're going to have a faster payback. But in normal industries, we're seeing it's in a few years that you actually break over and it's a positive return on your investment.
Do you feel that government contracting is set up to allow for the long-range horizon view, or is it just an up cost, whoever's cheapest to produce gets it? I mean, do you feel that we factor ROI into as we evaluate different options?
I'm probably not the best to comment on it at this stage, just because of where we are, where we just have moved into the commercialization phase of things. Up to now, it's been more of the development phase, working with the Navy. But one thing to share is additive manufacturing, 3D printing, it's new, right? And so if the military is going to demand volume of these type of solutions, that means the suppliers need to go out and procure 3D printers, set those up, and that process can take over a year to do. And so any vision or any kind of visibility into the horizon of demand and volumes is extremely helpful, because this isn't just hire contractors to go build it. This is go buy new machines, new equipment that will be better at manufacturing.
Okay. Carno likes cold, so how about the moon or Mars?
Yeah, so outer space is something that's on the theoretical. We think it can be done, but time will tell. We got to get things deployed here in the U.S. first.
Roger. Thanks. Mr. Chairman, I yield back.
We look forward to working with you. I want to come visit your lab. Smart things, new things that work good and are mobile are fantastic. And we got to make it work. The islands are going to be a challenge for the Navy and the Army and some others. Guam is the typical example. Labor issues, cost overruns, all these things are going on in Guam. We got to get that straight. So I'm hoping to take this panel over for a visit to the islands again, and keep that on our forefront, because it's real issues. Thank you all for being here. I appreciate every one of you. Got one question for you. If we were using your generators when the power went out in Texas, would they have worked?
They would have worked, yeah. We wouldn't have had the freezing buildings and facilities that we had, and the health issues that we had as well.
Okay, good. Thank you. Thanks to the panel. We're adjourned.